Today's lesson is going to cover 20-2, which is the converse of the Pythagorean theorem. So we're going to talk about what the converse is and actually use it to solve some problems. But the bulk of our lesson today is determining whether a triangle could be classified as acute, right, or obtuse. So we're in our Springboard book, page 286. And you're probably going to need a calculator for today's lesson, so make sure you have that with you. Let's go ahead and get started. Okay. So we're looking at this picture here. It says one of Sarah's customers designed the kite shown. The customer claims that triangle QRS is a right triangle. So in the previous lesson, we talked about the Pythagorean theorem. So the Pythagorean theorem says if a triangle is a right triangle, then the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of each leg. So if we look at this problem, remember we can write an if-then statement that says if P, then Q. So our P here is if a triangle is a right triangle, the Q would be the then statement. So the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So to write the converse of that, remember the converse just says if Q, then P. We just reverse the order. If you remember that from Unit 1. So if the square of the lengths of the longest side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So what this is saying is if we have a side where we have a squared plus b squared, if that in fact equals c squared, so if this holds true, then we have a right triangle. We can prove that that is actually a right triangle. So in this picture, we have triangle QRS. So we'd have to take our longest side, so that's 58. That squared would have to be equal to 40 plus 42 squared. So we'd actually have to show, is 40 squared plus 42 squared, does that in fact equal 58 squared? Okay, now I already worked this out in my calculator. But 40 squared plus 42 squared is 3,364. 58 squared is the same thing. Okay? So 3,364 is in fact equal to 58 squared. It's the same number. So we can say that yes, okay, QRS is a right triangle because this is true. Okay? All right, so write an algebraic proof to show that A, B, and C form a Pythagorean triple, and any whole number multiplied to those numbers is also a triple. And so I kind of just copied the proof on here for us, but say we take a Pythagorean triple. Let's use 3, 4, 5, because that's our most basic kind of one, smallest numbers. What they're saying is if you take any whole number and multiply it by all three of these, so let's say we take 3, 4, 5, and we multiply everything by 2. So that would give us 6, 8, 10. We would have to prove that that is also a Pythagorean triple. So meaning the Pythagorean theorem holds true. Well, let's check that. 6 squared plus 8 squared, does that equal 10 squared? Well, 36 plus 64 is in fact 100, which is equal to 10 squared. Okay, so what that says is you can take any number and multiply it by a Pythagorean triple and form a new Pythagorean triple. Okay, even if I took this and multiplied everything by a 3, that would give us 9, 12, 15. Okay, which is also a triple. So we kind of have an infinite amount of Pythagorean triples here. If you start with one triple, you can multiply it by any number, which will form a new Pythagorean triple. Okay, which would show a right triangle. Let's move on to the next page here. We're going to be talking about how to kind of classify triangles. So is it a right triangle? Is it an acute triangle, meaning the angles are smaller than 90 degrees? Or is it an obtuse triangle? Which means the angles are bigger than 90 degrees. Okay. So the way we have to do that first is by kind of testing a few things. Now, do we actually have lengths that form a triangle? Okay, so the first thing we have to check is, do the lengths actually make a triangle? So let me show you a little kind of website that lets us play around with the lengths of the triangle. So I can link these in Google Classroom for you. but let's go to those. Okay. So say I have these side lengths. I have 6, 8, and 12. So 12 being my longest side, 6 and 8 being my two shortest sides. Right now they're not forming a triangle, but let's see if I just kind of move these around. Okay. Yay, I made a triangle. If we adjust some of the sides here, maybe I can make one shorter, make that one a little bigger. Kind of take some trial and error here, but let's see if I can do it. Here we go again. I made another triangle. But let's look at something like this, where our side lengths are the same, and then we have a third longer side. Okay, it doesn't matter kind of how I move these lines. I'm not forming a triangle at all. Oh, close. Did I get it? There we go. Let's maybe make this maybe a little smaller. Okay, same thing here. I can kind of try and move it around, but I don't know if I'm going to get there. Well, this could be an equilateral triangle because they're all the same. Let's make this one 12, 5, and 5. Ooh, maybe I'll make this. That kind of can't see it very well. How about like this? Okay. So if I look at these two short sides being 5 and 5, my third side is 12. Here is one where no matter where I move it, they're never going to touch. Okay, they're never going to be long enough. Even if I just make this a little bigger. Okay, still, same thing. Okay, even if I make it 6, 6, and 12, never going to work. So there's a pattern here we notice about the lengths of the sides. Do you think you can see what would make it a triangle? Okay, so here's the little thing that we have to know. Our two shorter sides, okay, if we add those together, it has to be bigger than the third side. Otherwise, we're not going to form a triangle. So say we had this as 10. Okay, 6, 6, and 10. 6 and 6 is 12. I should be able to make a triangle. I'm very close here. Take some messing around, but there we go. I made it. Okay. So what we have to say is our two shorter lengths, if we add those together, it has to be bigger. And we even showed that can't be equal to. If I make these 5 and 5 and 10, can't be equal to. They have to be bigger than in order to form a actual triangle. So that's one thing we have to check first. So let me write that down for you. I would make sure you write this somewhere. Okay, our sides A, okay, plus B has to be bigger than our C side. If A and B added together are not bigger than the third side, then it is not a triangle. So this must be true. Okay, once you establish if it's a triangle or not, then you can actually try to talk about if it's acute, right, or obtuse. So basically, we just have to examine the relationship between A squared, B squared, and C squared. So again, I have another kind of thing we can look at for that. So Pythagorean theorem. So here we have a 6, 8, 10 triangle, which we already talked about, gave us, okay, a right triangle. But let's kind of just play around with the vertices. So say I make this an acute triangle. So acute meaning that angle is smaller than 90 degrees. Look at what we have here. So our A squared plus our B squared is always going to be bigger, okay, or greater than our C squared. Okay. If I make this an obtuse triangle, meaning I make that angle bigger than 90 degrees, we could see again what's happening. Our A squared plus our B squared is smaller than our C squared. So that's going to be true for any acute or obtuse triangle. So let's kind of go in here. So the first one, if we have A squared plus B squared, if that ends up being equal to C squared, that's how we can prove that something is a right triangle. Okay. And then on that little kind of exploration thing, we talked about if A squared plus C squared, if that ended up being larger or greater than our C squared. So again, that happened when we had something smaller than 90 degrees. So if A squared plus B squared is smaller than our C squared, then we have an acute triangle, which means all the angles will be less than 90 degrees. So the last one, if a squared plus b squared is less than c squared, smaller than c squared, then that's how we can tell if something is obtuse. So make sure you have those 3 written down because those are very important. Okay, if you have that written down somewhere, you should never get these wrong. So I'm going to go through a couple of examples here. We're just going to prove, okay, test it. Determine if it is a right triangle, acute, or obtuse. So really we just have to test what a squared plus b squared and how that relates to c squared. So let's look at a here. So our longest side is 37, so that's our c. So we have to check what 12 squared plus 34 squared. We have to see how does that relate to 37 squared. So I'm going to use my calculator on this. So we have 12 squared plus 37 or 34 squared. So there's 1,300. And we're going to check how that relates to 37, our longest side squared. We have 1,300 and 1,369. So this becomes 1,300, 1,369. Okay. Well, if I look at that, okay, 1,300 is smaller than 1,369. So if something is smaller than our c squared, that means that this triangle is obtuse. Okay. Let's look at B. B looks a little nasty because of the fractions, but really, if you notice, we all have the same denominator. So I'm really just going to look at that numerator here, 6, 8, and 10. So 6 squared plus 8 squared. How does that relate to 10 squared? Do you have a guess of what this is going to be already? Well, we can check it out in our calculator just for fun. So 6 squared plus 8 squared. That's 100. And we already know 10 squared is 100. So in this problem, our things were equal to each other. So this was a right triangle. Hopefully you already knew that because we just talked a lot about how 6, 8, 10 is a Pythagorean triple. Okay. One more, let's look at C. We have 20, square root of 42, and 21. Okay. Now 21 is probably going to be our biggest side. We can check that really quick if we want. Square root of 42. Yeah, it's 6.4. So this is my C. That's my biggest side. So we'd have to check is how 20 squared plus the square root of 42 squared, how that relates to our c squared. So how that relates to 21 squared. So again, I'm just going to use my calculator. So 20 squared plus the square root of 42 squared. No, put that on the outside really quick. Squared. And then we have to see how does that relate to 21 squared. Okay, so we got 442 and 441. So 442, 441. Well, looking at that, 442 is bigger than 441. So when our a squared plus b squared is larger than our c squared, that means our triangle is acute. Okay, so again, you just have to look at what the problem gives you, okay, and see how a squared plus c squared relates. A squared plus b squared relates to our c squared. Okay, if you know those inequalities and you've written this part down, then you should never get it incorrect. Okay. So I'm going to have you guys try number 6, and then that's kind of the end of this lesson. So Sarah's best customer wants to design a kite in the shape of a triangle with these side lengths, 27, 34, and 45. So classify that triangle. So 45 is your largest side, so that's your C. Go ahead and classify that. See what kind of triangle it should be. Okay, if you did it right, you should have got that it is an obtuse triangle. Now your book does this backwards. I'm not sure why, but you would just have to test 27 squared plus 34 squared. How does that relate to 45 squared? So you should have gotten that it was less than, making it an obtuse triangle.